Hello and welcome to the latest B live stream. Today in the chat we've got Thibaut, we've got Alex, and we have myself, Joshua. So this week we're going to be working on a variety of things that are mostly just a continuation of the work I've been doing over the last week, and also a few of the things that Thibaut has been working on. So I'm going to go. Perfect time for builders downstairs to start. I hope they're not going to be too loud. So, over the past week, Thibaut has been working on a new extension to the way we do things in B. This is going so well. So, I'm going to lose my train of thought in a minute. So Thibaut worked on this worker trait last week, I believe, and this worker trait is intended to tie together all of the workers that run in B. So the changes that occurred over the last week were that this worker trait got tied to this node type. So node is a thing that implements the node trait. So in this case, the node trait looks like, here we go, this, and it's got this is going to be very inconvenient. I really hope they stop. So this node trait contains a few things it can do at the moment. There's a way to construct it, and there's a way to spawn tasks using it. So tasks are tied to each worker. So these tasks run asynchronously on the node, and so you might have one, maybe two tasks per worker that are doing a variety of odd jobs in order to facilitate the node and allow it to run. So this is tied together with this node builder type. It's right below me. It's right in the wall, right below me. I've got no idea what they're doing. So this node builder type is used to build up a node, and it's a type that users of B will be interacting with in order to create nodes and add their own extensions to the node. And it's intended to be very extensible through the worker trait. So in time you'll be able to add your own workers to it, and give them configuration and things like that, and allow them to run tasks in the background and do all of the sorts of things you'd associate with plugins that would be tied to the node. So this node builder, as mentioned in the live stream last week, it builds up a graph that tells the node builder what order it needs to start the workers in. So for example, you might have a worker named A that needs So for example, you might have a worker named A that needs to depend on a worker named B. And so the relationship between these means that you need to start worker A, or rather worker B, before worker A. I should probably have changed the ordering of the letters I chose. and conversely, it means that worker B is required to it means that worker B is required to also shut down first in order to correctly handle all of the data that it might need to flush to the data structures of workers A. Double sound. Well, at the very least, it's going to obscure the echo that seems to happen on every live stream I do. So there are a few changes that I need to make to the work I've been doing on integrating the storage layer with all of this, because this new worker trait and node traits setup have changed up the code base a fair bit. And so what I decided to do was to transplant a lot of my code, because it became increasingly difficult to rebase things, and I realized it wasn't really worth the effort of rebasing a lot of things when it was basically all one large change, and it made sense to transplant some code over instead to avoid quite a few hours of pointless work. So one thing we need to do is we need to take into account the fact that the storage layer and the tangle both need to be accessible to workers so that they can respectively be used to store state. So, for example, a worker might need to communicate with the tangle and store a transaction in it, or it might want to take a look at the transactions in the tangle and do something with them. So to facilitate this, we're going to need to create a worker that specifically handles the tangle, so then other things can depend on it. So to do this, I'm going to create a new worker that is meant to handle and manage the tangle. So I'm just going to keep the definition of the worker trait here. I think Thibaut has added some some changes to master recently, so I might have to rebase on them at some point, but at the moment I'm going to try to work around that. So we're going to create a new file for this worker. We're going to import the worker trait. Let's just check I've got the path correct. No. So this tangle worker is going to be used for controlling the startup and the shutdown of the tangle, and we're also going to need a storage worker as well at some point. We'll probably be creating that as well in this live stream. So I'm using this this crate called Async trait, and it allows us to declare traits that have asynchronous functions. So the way async works in Rust is that whereas most languages will box their their futures, Rust will try to perform static dispatch, and it does this through what effectively amounts to global type inference, where an asynchronous function will return a type that is unknown but conforms to a particular interface, in this case the future interface. But that has problems with traits because Rust doesn't yet support a feature known as higher ranked types, so or rather higher ranked kinds. So these are you can sort of think of them as types that need to be specialized in some way. So for example, a vector of t might, or rather a vec can be specialized with a t in order to turn it into a concrete type. And so in the same sense, we're going to want to have a type, an asynchronous type that's returned, that we only know when the trait implementation is resolved at compile time. But Rust currently doesn't support this, and so the way we do it is using this async trait macro, which basically turns all of the asynchronous functions in here into functions that return a boxed future. So it's not quite as efficient as it could be, but it's better than most languages still. So we're going to implement this this interface. I'm a bit concerned. I think I should probably have rebased on the changes because this API might not support all of the things I want it to. Okay, so at the moment I'm just going to copy most of the work from another worker, mainly because it's easier, and programmers are notoriously lazy. But then that just means we automate a lot of things, so that all works out in the end. So when we start the tangle worker, we're going to want to be inserting the tangle into the node in some way. So we're going to want to be setting it up. So to do that, we need to make a few changes to the node trait. So one of these changes is that, this might get a bit complicated. No, that should be fine for now. Okay. One of the things we're going to want our node trait to do is to inform the rest of the code base which version of the storage it's using, or rather which storage backend. So B will eventually support multiple storage backends. So for example, the current one that we're working on is RocksDB, but it may support SQLX and various other things like that. I did a live stream previously that mentioned this. So for this we just need to import a trait, which is the backend trait. Here we go. And we're going to use this trait in an associated type, so that now our node can be bound to a particular backend, and we can change that out at compile time. So I'm going to leave this as is for the moment and work on the storage worker as well, because we're probably going to need that first, I've just realized. So these workers are unlikely to do much work in their own right, but what they will be doing is acting as a way to control the lifetime of the tangle and the storage and make sure they're started up and shut down at the appropriate time. I see Lue made a joke in the B chat about workers being everywhere in the code base and building here, which I only just got. I was quite slow on the uptake on that one. So yes, our storage worker. It's going to have a configuration it needs to take. So this configuration in this case is going to be the same configuration as the storage backend. So I think this trait may be expanded later to, in fact, let me just check that this is visible. No, it's not. Remove this. So this trait is probably going to be expanded later to take some sort of configuration type that will be applicable to each of the backends. So what I'm going to do for now is no, I'll leave that out at the moment, and have our storage worker take a string and put this here. So later on we'll be able to provide a per backend configuration. So the next thing we're going to want to do is to actually start up the storage backend. So you can see we've got a function here called start, which is going to start it up. I don't believe this config type is actually passed in yet. So what I'm just going to do is create a temporary just so that we can get this to compile, because that's always the first stage in writing a successful Rust program. And then start up the backend. So so what we're doing here is we're awaiting on the result of it asynchronously, and then we're propagating any error that may occur. So in this case, the error is just going to be a dynamic error, and I'm sure this might change at a later date into a concrete type. So here's the part where we need to effectively register the backend with the node. But this bit's a bit strange because we don't have this implemented yet. So this is a thing I've only briefly discussed with others, but we want a way of registering effectively a global resource with the node, a thing that is going to be accessible to all other workers. So I'm going to try to implement that now. So we're going to add 2 functions. And they are going to let us register a global resource like so, and then also access the resource. So this is going to be quite useful when it comes to accessing the storage. I'm just going to check the chat. Right. So now it's time to implement these, because we're definitely going to get a compiler error if we try to do this. Whoops. I've made it point to the wrong path. That could be moved outwards to the path outside it. I think I'll do that later. What am I doing wrong here? Let's see. Oh. That was not very clever. Okay, so as expected, we're getting an error because we're not registering or we're not implementing all of these things that we've just added. So what we're doing here is we're just parameterizing our node over this backend type. And the reason we're doing this is that it'll allow us to bind the node to a particular storage backend. Okay, that should be all fine. And we'll get more errors still. Ooh, that's something that needs to change. So the problem here is that Rust wasn't able to safely ensure that our backend type was thread safe. So the way we're going to do this is by putting these bounds on the trait that say, first of all, that the type can be sent between threads, that it's synchronous across threads. So you won't end up with, say, a race condition if you try to read and write it across threads. Race condition is the wrong word here. You won't end up with undefined behavior if you do so, because it's still possible to have a race condition with something like a mutex. And the static lifetime says that this type is not bound by a particular lifetime and it can live as long as is required, which is important if you have threads, because the threads might live as long as are required. So, and now we have the rest of the errors. So this is going to change very slightly with the modifications that have been made on master that I need to rebase with. So I'll do that at a later date. But for now, we probably won't get the node compiling within this live stream, just as a result of that. Going to want to, so the resources here are stored in this data structure known as an AnyMap, and an AnyMap is a thing that you can think of as being a bit like a hash map, except rather than mapping a key to a value, it maps a type to an instance of that type. And this is quite a useful thing because it allows you to use a type as a meaningful identifier. And this is a pattern that's quite common if you've ever worked with an ECS system for game development, so an entity component system, where you have this notion of global resources which effectively act as a singleton, but are identified not through a particular variable binding, but by their type. So in a similar way, we're going to have resources that may be globally accessible. I think actually eventually, I'll probably have to discuss this with Thibaut, but I think eventually it might be a good idea to have tasks as a resource. But there are a few things that need to be decided before doing that. So first of all, I'm just going to open the documentation to just check I've got this method call correct. Yep. Okay. So the method here is going to allow us to fetch a reference to any particular resource. So in this case, a resource might be the tangle or the storage layer. So going back to our tangle worker, our storage worker rather, we're going to register the resource, and then it's going to be available for other workers to access. So another worker will be able to do something like this. Node dot resource, and then storage where this type is going to be the type of the storage. But the problem here is that it's a bit inconvenient to type what's effectively going to be this. So it would be nice if we had a method that looked more like this, and it fetched us an immediate reference to the storage. So I'm going to implement that now. Another change I want to make is to allow a resource to have a reference taken to it, and have that reference extend its lifetime arbitrarily. And so the way I'm going to do that is with reference counting, in this case atomic reference counting, because it needs to be thread safe. And contrary to popular belief, atomic reference counting is not the greatest sin ever. It's okay provided it's not being done in a hot loop, but once you have an atomic reference count to something, it's basically free to access the thing inside that reference. It's just a single pointer in direction. So in this case, we're going to insert an arc of that resource. Then we're going to get an arc back, however, a reference to an arc in case it doesn't need to be cloned. Right. So now, as a default implementation on the node trait, I'm going to add a method that gets a reference to the storage of this node. Let me just check this for consistency. Yep, that's all correct. Okay, so this default implementation means that it doesn't actually need to be directly implemented by anything that implements node. It'll just automatically be there. So from now on, or rather from here, we also want to set the same thing up with the tangle worker. So our tangle worker is a little bit different in that the tangle relies on the storage in order to store things in the tangle. So we have this system called eviction, where when the tangle in memory gets too full, it will start to push things into the database, and then if it's trying to fetch a particular item and it's not in the storage, or rather it's not in the cache in memory, it'll then fetch it from the database as well. So our tangle worker is going to have a dependency. It's going to be dependent on our storage worker. So what I'm going to do is I'm going to import the storage worker. No, actually I'm going to and then make the tangle worker dependent on it. So the way we do this is through the worker trait. We have, or we should have, yeah. So we have this depth associated constant, and this allows us to specify all of the types, or rather all of the worker types that we are dependent on for each worker. So in this case, I'm just going to move this to the top to make it neater. We're dependent on type ID of tangle worker. I'm just going to need to import this. So now this means that the tangle worker is always going to be starting up after the storage worker, and it's also going to shut down before the storage worker. And this means that it's going to get an opportunity to write back all of the changes to the storage layer and write everything back into the database. Hi, Steph1860. I hope you're enjoying the stream. So the way we're going to do this is fairly similar to the storage worker. It's the same kind of idea anyway. So we start off with our tangle. I've not transplanted the changes that are needing to be made to the tangle over yet. So I can't properly complete this part of the stream. But the way we'd be doing it is we'd create an instance of this tangle here. What we're going to add later is we're going to parameterize this with the backend so that it knows how to talk back to the storage worker and feed all updates back. But for now, what was I saying? Yeah, but for now I'm going to leave that as it is and just pretend as if we built that infrastructure at the moment. So here we go. This is going to create a new instance of the tangle, register it as a global resource. I say global, in this case it's not actually global. It's not global to the entire program. It's only global to that particular node instance, which is a bit less evil than global resources. Or it's a bit less evil than global variables. So you don't need to worry about us committing some horrendous sin. So once we've registered this resource, we're going to want to... oh yeah, first we need to import it. Just check that path's correct. Tangle mod, yep, that's correct. Okay, so this isn't going to compile, but I'm going to give it a try anyway, so let me re-enable that window. Okay, lots of errors as you might expect. I can fix a few of them here, so I might as well do that now. So the first thing is I need to add a few imports. Arc, that also needs importing. Arc. Also 2 parameters. Oh right, I know what I've done. Yeah, that shouldn't be there. Whoops. Okay, that's better. That's few errors. So it says that this type cannot be shared between threads. So what I'm going to have to do here is actually, first of all, I'm going to check how it's done on master just to cross-reference something. Oh right, okay, fair enough. Right, okay, so in that case, yeah, we're going to change this to map. It's a bit ugly. Okay, right. And a few more errors to get rid of. So I'm basically just proving to Rust that all of this is safe to use across multiple threads, because of course B is built using a parallel architecture, so there are things that run on different threads at different times. You need to make sure that everything is going to work correctly without problems. Okay. Might be able to remove that and just have the compiler infer it. Yeah, there we go. Right, so this is the last change that I can't yet fix because there are things that are in Thibaut's branch that I need to move across. But the problem here is that we can't insert because it's behind an immutable reference. So we're going to need a mutable one here, but this won't work with the current worker trait because we only pass in the node immutably. But I'll make this change here anyway. So at least now the error is going to be moved to somewhere else instead. Oops. Right, so now it started compiling other crates, so now we get more errors. Fun. Oh, that was a silly error. Yep, that was also a silly error. Okay, that got rid of a lot of them. Yeah, let me just check to make sure that that's the same type. Yep, it is. So I'm probably not going to fix all of these things at the moment because it needs a few changes to be moved from areas of the code base that are being actively worked on by other people. But as you can see here, we've created this chain of workers that are going to be started up in sequence. So now you might be able to have another worker, either one that's internal to B or one that's created by a third party that then depends on the tangle or the storage and uses their associated state to operate. Let me check my checklist of things to do. So we've got 10 minutes left. Okay, so what I'm going to do now is I'm going to start work on transferring, but also changing up at the same time a few of the changes I previously made and that need to be transplanted across. So one of those is to parameterize this with a type that's going to determine, oops, not this one, a type that's going to determine what the tangle should do if it's missing entries. So for example, if you decide to fetch a particular transaction that corresponds to a particular hash and it's not in the internal cache in RAM, it'll need to fetch it from the database. And so we're going to do that by providing this type parameter that tells the tangle how it can request those things. And this type parameter is going to implement this new trait that we're creating. And this trait is going to be called hooks. It's going to provide the interface to communicate with the outside world. So in this case the storage, but because this code is meant to be reusable, it could be anything, because you might be drawing data from a variety of different places. You might want to, for example, draw data from the network. Okay, so going to define this get method, which is going to take a reference to the hash of the transaction you're trying to fetch, and it's going to return, I think, yeah, a transaction and metadata. So now, when we have a request for a particular transaction, if it's in the cache, it's all fine. It just pulls it out of the cache, and that's all good. It's very quick. If it's not, it means we need to pull it out of the storage. So that's going to invoke this method here, and that's going to pull it out of the storage using this method on hooks. So that will be attached to the storage layer, or it'll be attached to the network in some cases. I can feasibly imagine a case where you might want an instance of the tangle that's backed up by a connection to say a Chronicle permanode or something like that, and it can fetch all of the long-term data about the tangle from there. And we've also got this insert function here, which is going to let us insert a new transaction into the backend. So what we're going to do now is we're going to have a default version of this. So we're going to have this type called null hooks, and this is going to be the default implementation, and it's not going to be backed by anything. It's just going to return an error if it tries to fetch anything or tries to insert anything. Actually, it probably won't return an error on insertion, but that's fine. So the default implementation is just going to return error and then unit and OK unit. So now that means it's very easy to create a tangle without needing to specify a hook, and it'll just default to an in-cache tangle only. And also we can build one that's going to be backed by a storage layer or by whatever other layer you want. And I call it hooks because these are effectively going to hook into the tangle and provide a way for the tangle to return information that we care about. So now we've got a default implementation in the case where tangle, or rather the hooks implements default, which is a thing I need to do for null hooks actually. So I've yet to wire this, or rather I've yet to wire the rest of the tangle methods into the hooks themselves. So that's a task that I'll be doing soon. I've already implemented this once. I want to make a few changes from that implementation though. But yeah, I think that covers that for now. There are 3 minutes left, so does anybody have any questions? I realise that this is probably a bit of an idiosyncratic stream with a lot of things going on, and it may not be clear exactly what I'm doing in some cases, but questions regardless. I'll leave it a minute to see if anyone replies. Right, I did have a few other things on my checklist, but I don't think we're going to get time since there's only 2 minutes left. But thank you all for watching. And I hope you enjoy your day. Yeah, I'm quite pleased with the hooks interface. It's a bit strange, but I think it works in that you mostly don't need to care if you don't need to use it, because it's got the default implementation. Okay. Thank you for joining the stream today. Bye.